Hi everyone, welcome back. In this session, we will explore Pandas Crosstab function, which produces very similar results as pivot table method, but allows us to count occurrences in a cleaner way and with more functionality. We will be using Superstore dataset today. This is a customer transaction table that has information about the customer such as order date, order ID, customer name and so on. Let's import the necessary Python packages and read the Superstore dataset. I have imported the necessary libraries pandas and numpy, read the CSV file, Superstore dataset, and you can see here there are 9,994 records where for customer transaction table you can see order ID, order date, ship mode, customer ID, customer name, sales and profit and so on. I'm using this piece of the snippet of code to clean the columns name, and this is how our data looks like. Before we proceed, let's understand crosstab function. The crosstab function is built specifically for the situation of counting co-occurrences of values between two or more columns. The names come from cross tabulation, which is the more generic term used in data analysis outside of pandas. They are also known as contingency tables. It has many of the same parameter name as pivot table method and is used similarly. But by default, it will compute the size of each group so that there is no need to set the aggregate function parameter in crosstab function. Let's do an example and see how we can use crosstab function in pandas and generate a contingency table. df underscore basic equal to pd.crosstab index equal to df ship underscore mode columns equal to df segment, and let's run the code. df underscore basic, and you can see here we have calculated the frequencies using crosstab. Alternatively, we can count frequencies using pivot table. Let's see that. df underscore pivot equal to df dot pivot underscore table method index equal to ship mode equal to segment, and we have to call the acfunc method, and I'll be using acfunc size. Let's run the code. df underscore pivot, and you can see the results are identical. You might be wondering why there is a need to even know about this function. There is one big benefit of using the crosstab function, and that is the ability to return the relative frequency with the normalize parameter. This isn't easily doable with the group by or pivot underscore table method. The crosstab functions allows you to normalize over the rows, columns or all of the data. Now let's say if we would like to see the contribution of different ship mode across the segments in normalized format. When I say normalized format, it means in the form of percentages. Let's see that, how we can do that. df underscore index equal to pd.crosstab. Let me copy and paste. Now, since we want to see the contribution of different ship modes across the segment, what we need to do is we need to call the normalize parameter. Since we want to see the contribution in the form of percentages, I will put up here index. Let me round the data to 2 decimal places and let me multiply it by 100. Let's run the code. df underscore index, and you can see here the contribution of first class across the different segments is 50%, corporate is 32% and home office is 18%, which constitutes 100%. Similarly, for same date is 58% consumer, 21% is for corporate and home office is 21%. And this is how you can create the normalized contingency table. And let's say if you would like to generate that how different segment contributes to different ship mode. In that particular case, what we need to do. Let me copy and paste this code and let me change from columns I have changed index to columns and let me run the code. df underscore columns, and you can see here consumer has constitute 15% to first class, 6% to same day, second class is 20% and standard class is 60%. Whereas home office constitute 16% to first class, same day 6%, second class is 18% and standard class is 60%. So this is how you can use normalize parameters and get the report in or the contingency table in percentage format. Now there is one more parameter which is called all. Let me show you that. df underscore all. So here we have calculated the relative frequency against all of the data by setting the normalize parameter to all. What does it mean is we have 9,994 records, and if you will divide 769 by 9,994, 769 divided by 9,994, it will give you, and let me multiply it by 100. If you round it off, it is somewhere around 8%. Let me change round to from 2 to 4. So you can see here it is 7.69. For corporate it is 4.85. If you will divide 485 by 9,994, let me multiply by 100. You have got the same output, which is 4.85%. You can also add margins as well by setting the margins parameter to true. Let's do an example. Let me paste this piece of code, df underscore margins. Let me remove normalize for the time being. Margins equal to true. Let's run the code. df underscore margins, and here we go back to raw counts and add margins for all rows and columns. So you can see here the total number of transactions for first class is 1538, whereas for standard class is 5968. As well as you can also see the consumer segment has 5191 transactions, whereas corporate has 3020, as well as home office has 1783 records, and overall we have 9094 transactions happened in Superstore dataset. When normalizing the data, the margins calculated depend on the direction of the normalization. What does it mean is, let's do an example to have a fair understanding. df underscore columns underscore margins, margins equal to true, round to 4, columns. Here we add margins when normalizing down the column. We can use this margin to determine the degree to which segment is overrepresented in each ship mode. For instance, you can see standard class is contributing 60% of all shipping to the customers, whereas for consumers first class is contributing around 15% of all the transactions. And you can see overall contribution is also mentioned here for each and every ship mode across the segment. For example, first class is 15.39. So you can see here first class is underrepresented in consumer class, whereas you can see here for corporate it is around half a percent is overrepresented. However, if you will see here for same day, consumer class as well as for home office, there is an overrepresentation. It is more than 5.43%, whereas for corporates, they are not concerned about the same day delivery of the products. It is way lower than the overall same day deliveries, which is 5.43%. So this is how you can use margins to have fair understanding that how the overrepresentation and underrepresentation is happening. While crosstab and pivot tables are quite similar, the key advantage of crosstab is its built-in ability to easily normalize values across rows, columns, or the entire table. Something that isn't as straightforward with pivot table. This makes crosstab especially valuable for quick contingency analysis, handling both counts and aggregation in one step. That concludes our session for today. Thanks for watching and have a great day.